video 1 for the chapter 9 test redo. Again, video 1 for those people who have to do or are watching video 1. Problem number 12 was the first one. And I'm going to move very quickly on this. Remember, you got to show all your work, so show everything that I show. I look at this problem, and I know since it's got this drawn in here, that's an altitude, so we're either going to use the altitude or the leg theorem. In this case, I look here, we got an X out there for one of the legs of the big triangle, so that means we're using the leg theorem. When we use the leg theorem, the proportion for the leg theorem, the leg goes here, the leg goes there. On top should be the whole hypotenuse. Well, they didn't tell us the whole hypotenuse, but we can find it by adding those two. 3 plus 10, and that's 13. And then the part that goes on bottom down here is the part of the hypotenuse. This is our hypotenuse, and it's split into two parts. This part, that part. But we only want the part this time that's adjacent to the leg that we're dealing with. Well, the part that's adjacent to that X leg that we want to find is the 3 right there. So 3 goes on bottom. Cross multiply, end up with x squared equals 39. Take the square root. Your answer could be left. 39 is not a perfect square number, so your answer could be left as just the square root of 39. Or if you use your calculator and take the square root, you end up with about 6.2. I would accept either one of those answers. Next one you had to do was number 1. Same kind of problem. Got an altitude drawn in a right triangle, so an altitude drawn to the hypotenuse. This time this part's 4, that part's 16. This time we're looking for this. So instead of using the leg theorem, because we were looking for a leg over here, now we're looking for the altitude, or we're dealing with the altitude. So we're going to use the altitude theorem. Altitude theorem is another proportion. You set up, the altitude goes here, the altitude goes here. On top right here is part of the first part of the hypotenuse. On the bottom over here is the second part of the hypotenuse. So altitude is x, altitude's x, it goes in both those spots. On top over here, it doesn't matter which part's which, we just take one or the other. So that's 14, then the other part is 16. We cross multiply, you get x squared equals, multiply that way, you get 64. Take the square root of both sides. Square root of x squared is x. Square root of 64 is 8. So this one used the leg theorem. This one used the altitude theorem. Next one you had to do. For the first video, you had to do number 15. Number 15. Number 15 looks like this. 21 here, 75 here, x here. If we know two sides of a right triangle and we're trying to find the third side, then we're going to use Pythagorean's theorem. The only thing you need to remember when you're using Pythagorean's theorem is that side across from the right angle is the hypotenuse, so it has to be the C in the setup. So we got 75 squared over there on the side by itself. And on the other side we got 21 squared plus our other leg is just x, so x squared. We grab our calculator and we do 21 squared and we do 75. 21 squared is 441. 75 squared is 5625. We want to get the x squared by itself, so we subtract 441 on both sides. These cancel out, you're left with x squared equals, 1 second, 5,000. Subtract these, you end up with 5,184. Then we got to take the square root, grab your calculator, take the square root of 5,184. and you end up with x equals exactly 72. Next one you had to do problem number 2. Problem number 2. Got this. It's a 45, 45, 90 triangle. We're looking for this. Oh, and it says you're looking for x, but it's a y. Just figure out that you're looking for y, not x. And this side is 15 radical 2. In a 45, 45, 90 triangle, sides across from the 45-degree angles should be labeled L and L. Side across from the right angle is L times the square root of 2. You could have used sine, cosine, tangent, stuff like that on this, but this is probably the easiest way. We set up that equation right there. L radical 2 equals 15 radical 2. You guys are making these radicals too difficult. Divide both sides by the square root of 2. If you're multiplying L times square root of 2, then to get L by itself, you divide by the square root of 2. Divide that side by the square root of 2. These cancel out. You're left with just L equals over here. The radical 2's cancel each other out again. You're left with L equals 15. Well, if L equals 15, then this side over here, where Y is, has to be 15. And again, I know it says find X, but we're actually finding Y on that problem. Next one you had to do was number 5. Number 5. Number 5, you had to remember, if this is 6 and this is 6, then these two angles here have to be congruent. Well, if they're congruent, then both of them are 45. We're looking for X over here, another 45, 45, 90 triangle. Side across from the 45-degree angle should be labeled L. Side across from the other 45-degree angle L. This side should be L times the square root of 2. We set up our equation from that. Well, that just tells us L equals 6. Nothing to solve there, so anywhere we see L, we can stick in 6. So right over here in place of L, we're going to stick in 6. And that tells us that X has to equal 6 times the square root of 2. If you use like sine, cosine, or tangent, you get the decimal point answer, and I'll know what the decimal answer should be if you want to do it that way. Number 6 was the next one. Number 6, you got a 30, 60, 90 triangle. Again, you could use sine, cosine, tangent. I'm not going to. I'm going to use the 30, 60, 90 stuff. Side across from the 30-degree angle should be labeled L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle, 2L. This is the side we know this time, so we set up an equation from that. 2L should equal 50. Solve for L, you divide by 2. You end up with L equals 25. So anywhere you see L, you can stick in 25. Well, we were looking for this side over here, excuse me. So all we're going to do is put 25 in place of L right there. So that tells us that X has to equal 25 times square root of 3. Problem number 8 was the next one. This time you're looking for this angle. If you're looking for that angle, then you're using sine, cosine, tangent. So we need to label this triangle. That's going to be your opposite leg. That's the hypotenuse. This is the adjacent leg. We're looking at the hypotenuse in the adjacent leg, and your SOHCAHTOA, the one that deals with adjacent and hypotenuse, is the cosine. So when we go to set up our equation, we'll get cosine X equals A over H, or adjacent over hypotenuse. So 5 over 9. This is the one where on your calculator, first thing you got to hit is seconds. So you grab your calculator, You hit second, cosine, 5 divided by 9, close the parenthesis, and you end up with something like 56.25. So the angle is about 56.3 degrees. Next one, number 11. Problem number 11 looks like this. 42-degree angle. That's 12, that's x. Same idea here. It looks like we're going to have to use sine, cosine, or tangent. So I labeled the triangle. That's my opposite leg. That's my hypotenuse. This is the adjacent leg. Well, this time we care about the hypotenuse and the adjacent. In our SOHCAHTOA, hypotenuse and adjacent, that's the cosine again. Didn't mean it to be that way, but doesn't matter. So the cosine of our 42-degree angle, cosine of the angle equals adjacent over hypotenuse, so this time x over 12. That right there should say x over 12. All you do next, find the cosine of 42, so grab your calculator and hit cosine 42. You end up with 0.7431. Put a 1 underneath that. X here, 12 on bottom, and cross multiply. This is one of the easy ones because it's just going to be 1 times x is x, so whatever we get when we cross multiply this way is going to be our answer. So we take that times 12, and you end up with about 8.9. So the length of this side right here is about 8.9. Next one you had to do was number 3. Got this, that's x, that's 15, that's 17. This is one of them. You could have used Pythagorean's theorem, but I told you, and some of you didn't believe me, that you wouldn't get done with the test if you didn't remember some of the little tricks, and this is one of them. If this leg is 15, the hypotenuse is 17. This leg, it's one of the families, has to be 8, because it fits in that 8, 15, 17 family. So x equals 8 in this case. That's one of the families. If you wanted to do Pythagorean's theorem, then you'd have to set it up this way. 15 squared plus x squared equals 17 squared. And you'd have to solve that. And when you solved it, it'd tell you x is 8. Next one, number 18. A boat is 2,000 meters from a cliff. That's our cliff. The boat's out here somewhere. It says it's 2,000 meters from it. A lot of you having trouble drawing these pictures. So that's 2,000 meters. It's the distance the boat is from the cliff. If the angle of depression from the top of the cliff to the boat is 10 degrees. Well, from here to there, that's to the boat, but that's not your angle of depression right there. Remember, angle of depression is that angle. So we know that if that angle is 10 degrees, we could find this one just by subtracting from 90, or we could know that these two angles are alternate interiors, so this one's 10. And you can use either one. I'm going to use this bottom one being 10 degrees this time. How tall is the cliff? So we're looking for that. A lot of you forget to put your variable in there, so you have that extra part that goes in your equation. We label our triangle according to this. We're going to have to use the SOHCAHTOA stuff. That's your opposite side, or opposite leg. This is your adjacent leg. This over here would be your hypotenuse, but we really don't care about the hypotenuse this time. So we're looking at opposite and adjacent. Well, that trig ratio that uses that is the tangent. So we do the tangent of 10 degrees equals opposite over adjacent, so x over 2,000. We take our calculator and we find the tangent of 10 degrees. Don't hit second. 0.1763. Put that over 1 equals x over 2,000. When we cross multiply, this is a nice one again because We multiply that way and we just get X, and all we got to do is multiply this way. So we take that number times 2,000, and we end up with about 352.6 or 0.7. And that is how tall the cliff is, and that's in meters. So the cliff's about 352.7 meters tall. The next one you had to do was problem 20. Problem 20. Problem 20 says a 50-meter vertical tower is braced with a cable secured at the top of the tower. That helps you draw a picture. That's my tower. Whatever this tower is for, that's my tower. It's got a cable coming from the top of the tower. Well, if the cable is bracing it, the cable is going to go down to the ground. And it says that that cable is down at the ground 30 meters from the base of the tower. Well, the base of the tower is over here, so that means this distance right here is 30 meters. Hopefully the tower is making a right angle with the ground. We know the tower is 50 meters tall. They want us to figure out what angle does the cable make with the tower. Well, where does the cable touch the tower? Right here. So we're looking for that angle. So we're going to use sine, cosine, tangent. That's your opposite side or opposite leg. That's your hypotenuse over there, but we really don't care about the hypotenuse this time. This is your adjacent leg. So we care about opposite and adjacent. Well, that's tangent, so we're going to do the tangent. We don't know the angle, so tangent of x equals opposite, the toe apart, opposite over adjacent, 30 over 50. This is one of them where we're going to hit second first because we're looking for the angle. So we're going to hit second on our calculator. So you hit second, tangent, 30 divided by 50, close the parenthesis, and you end up with about 30.96. Well, since we're dealing with an angle, we're probably going to round that off to about 31 degrees. X is about 31 degrees. That angle that the cable makes with the tower is about a 31 degree angle. And the last one you had to do, if you're watching this video, is problem 21. Problem 21. They give us a rectangle. They tell us it's a rectangle. And this side's 12. They draw in the diagonal. This angle happens to be 60 degrees. Well, then we have a 30, 60, 90 triangle. In a 30, 60, 90 triangle, the side across from the 30 degree angle should be labeled L. The side across from the 60 degree angle, L times the square root of 3. The side across from the right angle is 2L. We really don't care about the 2L this time because we're trying to find the perimeter of this rectangle. We look here, that tells us L has to equal 12. Well, anywhere we see L, then we can stick in 12. So we know that this side up here is 12 times the square root of 3. Well, if this is a rectangle and this side's 12, then this side over here has to be 12. And if this side up here is 12 radical 3, then this bottom side has to be 12 radical 3. Since they want us to find the perimeter, instead of adding 12, 12 radical 3, 12, and 12 radical 3, you could just change these into decimal. So just on your calculator, take 12 times the square root of 3, and you end up with about 20.8. So this side is 20.8. This side over here is 20.8. And to find the perimeter, we want to add all those up. So 12 plus 12 plus 20.8 plus 20.8. We add all those up, and we're going to end up with the perimeter equal to, let's see, that's 24, 44, 64, 65.6. About 65.6, and we didn't have any units on this one. So that would be our perimeter. That's the video. Again, turn this in, and that'll help out your test grade. Whatever I told you it was going to help out. This is, again, video 1.